In this video, we're going to try and find the Taylor series for this function centered at 2. So the quick way of doing this would be to make use of this. But before I show you this method, let me show you our traditional slow way of doing things. Let me just remind you. So our traditional way of doing things would be to start out with our general power series. So our general power series, I don't know what it looks like. Let me just make it up. So it looks something like this. This is our general power series centered at 0. We would then make this transformation to our general series. So that would then, well, you making this transformation on this would be you shifting everything across by 2. You're shifting everything across by 2. So you're shifting everything across by 2. So it would look something like this. So the center would move to the 2. So our general power series would look something like this. And then so we are now centered. After applying this transformation, we are now centered at 2. And then we would differentiate this. We would then differentiate it. We would then differentiate it again and again and again, all the way to infinity. And then we would also differentiate this. We would differentiate it again. We would differentiate it again and again and again, all the way to infinity. And then we would demand the first derivative of this to match up with the first derivative of this. We would also demand the second derivative of this to match up with the second derivative of this. Third, to match up with the third. Even the original function to match up with the original function. So slowly, by us making those demands, by us making these demands, the purple line will slowly mesh on top of the red line. It will, if you take it all the way to infinity, it will slowly map itself onto the red line. So that would be our traditional way of doing things. I will continue in the next video. Okay.